Good morning and happy Monday. This is my last video for physics. I know, it's crazy. Gonna miss you guys and wish nothing but the best for you. Okay, so we've been talking about circuits and we've talked about series and parallel circuits. The last thing that we need to tackle is combining those two things together. So we're going to take series and parallel and we're going to combine them together. Normally this would be something I would spend a couple days on, but we're really just gonna kind of touch on it real quick, and I just want you to understand the basics of it, and that'll be good. And happy Star Wars Day. May the 4th be with you. So I'll be watching Star Wars movies. Okay, so here's a quick homework check. Go ahead and try this. What would be the minimum number of 65 ohm resistors that must be connected in parallel to produce an equivalent resistance of 11 ohms or less? So I'll let you try that. Well, there's two ways of doing this because the total resistance is the inverse of all of the inverses added up. So what you could do is just do 1 over 65 plus 1 over 65. See what that is. Put another 1 over 65, invert it, and keep doing that. Or you can kind of turn it into kind of an equation that would look something like this. The total resistance is equal to some number of resistors over 65, and you would do it, you get 5.9 as your number, so 6. So if you put 6 in there, it comes out to 11, or just under 11. Okay, combination circuits. What's combination circuits? Well, most of the circuits in the world today are not just series or parallel. If you were to open up your cell phone and look at the grid on there, it would be it's just a combination of series and parallel circuits. You open up your toy car and there's wires everywhere. Those are all just a series of series and parallel circuits. So here is what a basic combination would look like. So you notice that these two resistors here on the right are in parallel with each other. They look like our ladder. They're kind of stacked with each other. And then you have this resistor here that gets fed directly from the battery, and then this resistor which feeds directly into the battery. So these two resistors here in the middle are in series with the battery. So how does this work? Well, to understand what you have to do, what you do is you look at your circuit and you think, okay, are there any two that I can group together that are in parallel or series with each other that I can group together? So if we look at these two, resistors, those two are in parallel with each other. And if I put a box around them, they're in parallel with each other and they don't affect anything outside of that box. So what I can do is I can figure out a total resistance of those two. So if I do that, so our total resistance is 1 over R plus 1 over R, because these are both just resistances of R. So my total resistance of these two combined together is an equivalent of R over 2 when you kind of finagle the math, because this would be 2 over R, and then you invert it, so it's R over 2. So then what I can do is I can take my circuit up here and I'm going to redraw the whole thing. So when I redraw it, I leave this resistor and this resistor, the two resistors in the middle, I leave those, but then I replace this whole box with a new resistor that is the equivalent of the ones that I just found. So I basically combine these two and turn it into this one. And what you'll notice is now that this one has been changed. And this, again, this is not changing anything physical. This is just how we understand what's going on. Now that I've changed this, you notice that this one are in series. It's one circle. It makes one circuit. So then it's pretty easy to find your total resistance because, remember, resistors in series, you just add them up. So it'd be this resistor plus this R over 2 resistor plus this resistor. So you just add them all up and we get a total of 2.5 R would be our total resistance. And then the last thing we can do is we can rewrite that to show that it's 2.5 R. So that's all fine and dandy. So how would this work in, say a problem? So in the circuit shown in the diagram below, the EMF, remember EMF is just the voltage of the battery, is 12 volts. And each resistor has a resistance of 450 ohms. So the first thing we do is draw our picture. And the other thing I always do is I label my resistors. I give them some kind of a code. So I just number them R1, R2, R3. And you'll see why, but it's a good way to keep track of all your resistors. So we make our diagram, we put that each one's 450, label our resistors. So the question is, find the current. Well, the current, it wants the current supplied by the battery, so that would be our total. If it's coming out or through or from the battery, that's our total current. Remember, each thing is going to have its own value. So we're going to be using our equation here, but we need to find out our total voltage and our total resistance. Well, total voltage it gave us, that was 12 volts, so we're good there. But we still need our total resistance. So we're going to have to go back to our combining circuits idea. So if we look at our circuit, we ask ourselves, is there anything I can combine that is either in series or parallel with each other that I can just combine real quick into one single thing? Well, these two resistors right here on the bottom are in series with each other. One is directly plugged into the next. So I am going to group those two together. And so this is why we use this little nomenclature, because now I'm going to say that I'm going to make a new resistor called R23. And that's these two resistors combined together. And it's in series, so it's just R2 plus R3. So 450 plus 450 is 900. So once we do that, since we group those two together, I'm going to make a new diagram with my grouped together resistor in it. So I got R1 and R resistor 2,3 because those two are combined and they're now resistor 2,3. So from there, if you look at it, these two are now in parallel with each other. So to find our total resistance, we have to use our 1 over R equation. So 1 over total resistance equals 1 over R1 plus R1 over R23, which is this one. So we just do the math on it and plug it in your calculator or use your fraction skills, and we get a total resistance of 300. So all of these together give us a total resistance of 300 ohms. So now that we know that, we can go back up to our original equation. Total current is voltage over resistance, so 12 volts over 300 ohms. So we get a whopping 0.04 amps flowing through the circuit. All right, so I want you guys to try this one. What would be the equivalent resistance between points A and B? So basically all of these. Well, the first thing we need to do is label it. So I can label all my things. So I just label them R1, R2, and R3. And it said this last one is 25 ohms, so I put it there. So then you have to ask yourself, can I group anything together? Well, these two here are in parallel with each other. So we're going to start by grouping those two together. So we use our equation for grouping parallel items, the 1 over R equation, and that will give us an equivalent resistance for those two combined together of 17.2. Once I have that, then this resistor on the left with these two are in series with each other. So I can rewrite this as resistor 1, which was this dude, and resistor 2,3, which are these two combined It's just these two. And now they're in series, so you simply just add them up. And we get a total resistance of 29.2. All right, one more for you to try. So this one says find the total current. So first thing we would do is group these two together, since they're in parallel with each other. So I draw a box around them, and that's R1, R2. So we use our equation. Then we do the same thing for these next two, for 350 and 200, and we get these. Now this set of branches and this set of branches are in series with each other. This feeds directly into this. So if they're in series with each other, after we found out what the equivalent of them added up, them in parallel is, then we can simply just add them. So our total is R12, so these ones combined, plus R34, these two combined. That gives us a total current of 0. Well, use the equation I equals V over R, and then we get a total current of 0.121 amps. All right, so I want you to try the worksheet that goes with this. It's pretty straightforward. It's only one side. That is your last assignment. So, seniors, I wish you all the best. I hope you have great success in college. Hope to see you again. And juniors, I guess I'll see you around next year.